Well, hello, good morning, good afternoon, good evening, everyone. My name is Anton Ovchinnikov. I'm a visiting professor of decision sciences at INSEAD and a distinguished professor of management analytics at Queen's University in Kingston, Canada. And it is my great pleasure to welcome all of you to this webinar today about my research. Well, the title of the webinar is When Good Intentions Go Awry, the AI Bias Paradox, but I'll tell you more about research in a minute. And it's my great pleasure that Virginie Simon joins me from the Artificial General Intelligence Club here at INSEAD. Virginie will manage the Q&A session, to which we will get in about 45 minutes. All right, so today's webinar is part of the Tech Talk X series, and it is dedicated to exploring new technologies, their applications, as well as the impact on management, business, and society. For more information, visit the Digital@INSEAD website. Thanks to our sponsor, Accenture. And before we go into the details, let me introduce some webinar etiquette. So the audience is muted and the video is off. The chat is closed. Please use the Q&A tab to suggest questions for me and for Virginie. You can also vote the questions up so that we go to the questions that bring up the most interest. The webinar will be recorded and subsequently posted on the YouTube channel. And for technical issues, email digital@insead.edu. Well, with that in mind, let me take over screen sharing and go into the content of today's work. All right, so I'll share the entire screen, and here let me go to sharing the presentation. All right, so now I like this fancy title, but the real title of this work is a little bit different, and I think it will speak more directly to what we'll be talking about today. So the title is this: Anti-Discrimination Laws, AI, and Gender Bias, a case study in non-mortgage fintech lending. So this work was motivated by the troubling conversations with several lenders, where they observed that while they are adhering to all the legal requirements, their AI models, machine learning models, were nevertheless discriminatory towards certain minority groups. And as we had these conversations and we're thinking of doing this research, one such study, one very well-known case of this gender-based discrimination came up when Apple Card was accused of gender-based discrimination. Right? Basically, a man had a credit limit that was 20 times larger than his wife, even though she had a higher credit score. So, as you may know, Apple is not really the adjudicator of this credit process. It's in fact Goldman Sachs that is partner of Apple in this joint venture. And here is the response from Goldman Sachs, which again, I think wonderfully summarizes what is going on here, right? So the Goldman Sachs says, well, we hear you, but we have not and will never make decisions based on factors like gender. In fact, we don't even know your gender or marital status during the Apple Card application process. Right? So keep that in mind, but that Goldman Sachs, an American bank, does not even know the gender of the applicant. That will be important in a minute. And so with this in mind, this research really asks three questions, right? So one is, do certain anti-discrimination laws indeed paradoxically increased gender-based discrimination? Well, in this particular setting that we're studying, the non-mortgage fintech lending. Question number two is, 2 and 3 are kind of deciphering that a little bit, right? So why does discrimination occur, and what can firms do to reduce discrimination while managing profitability? All right, so now to answer these research questions, we look at the process of fintech lending. And so how does it work, right? So basically, a company uses historical borrower data. Now, realize borrowers are people for whom the loans were issued in the past, right? And for whom we may know if they defaulted on the loans or not, to train a model. Now, that model is predicting the likelihood of a default, right? Then there's a subtle distinction between the model that is trained and between the model that is used, and we will make a distinction between them, the training model and the screening model. So that screening model is then used to score applicants, right? And for each applicant, there is a default score prediction. You can intuitively think of these scores as the probability. Again, there is some nuance, but fairly technical between this score and the probability. But intuitively, to think of this as a probability of default, right? Now, if that probability of default is large enough, right, above some threshold, then the applicant is rejected. And if the probability of default is below that threshold, then the credit is issued, right? So that's essentially, in a very broad strokes, the fintech lending process. So what do we do here, right? We look at the legal discrimination, right, which basically are various directions and restrictions on data collection, on data governance, on model building, right? So sort of touched in this early part of this flow diagram, and this is what we manipulate in this study. I will explain how on the next slide. But what we measure in this study is the societal view of discrimination, right? Inequality, non-competitive wrong, one model is better at predicting men versus women, these kind of things. Again, I will talk a little bit more precisely at how we measure discrimination, right? But this is what we measure, right? So again, think of this, right? The laws and the societal views of discrimination, they both touch this flows in general, but the laws occur a little bit on the left side, while societal view is really on the outcomes of this. All right, so now how exactly do we manipulate this? So here we scanned the anti-discrimination laws around the world, and we realized that you can think of that there are three different regimes, right? Regime number one, an example of that jurisdiction would be Singapore, is where companies can collect gender data, they can use gender data in their training model, and they can also use their gender in their screening model, right? Regime number three is the United States, where companies cannot collect gender, and consequently, they cannot use it in training or screening models. So again, remember the Goldman Sachs statement. Well, don't even know your gender? Well, because according to the US anti-discrimination law for non-mortgage lending, companies cannot even collect gender. Now, for mortgages, they actually can collect, but this is different, right? So here we're talking about very precisely about the credit card type of loans. And then regime number two is in the middle. Regime number two is European Union, in fact, where companies can collect gender data and then can use it in training models, but they cannot use it in screening models. Now, what does this precisely mean, right? It means that your individual gender, the gender of you as an applicant, cannot be used to determine the outcome of lending decisions for you. That is, your gender, right, cannot be used to determine your own outcomes, but it doesn't mean that your gender cannot be used in some other way to determine something else, right? And again, this subtle distinction will turn out to be important a little bit later, and I'll comment on that one when we get there. All right, so then what do we do, right? So we use a very large data set here on about 500,000 borrowers, right, with the known outcome, right? So think of the data set consisting of the following kind of three big chunks, right? We have, and I will call it A later in the study, right, a column of gender, right? Then we have about 740 different variables, different columns of data about the borrower, amount of credit, occupation, marital status, et cetera, what material your house is built from. And then lastly, we have the known outcome, right? Whether the borrower defaulted or not. So this data set is publicly available on Kaggle. It comes from a fintech lending company called Home Credit. Everyone who wants can try to replicate our findings, or try to reach out different conclusions if they wish to. Right, the data set is available on a Kaggle competition. So as I mentioned, there are about 740 different features, which is about what typical fintech would have about you. So usually around 1,000 different features would be available for every borrower. Right, now realize here that gender can be predicted with very high accuracy from the other features. That is, if we know your education, work experience, profession, and so number of children, and so on, it's actually not that hard to predict someone's gender. But nevertheless, we have a separate gender column. Right, so here, again, one other technical nuance is that because we only have the data on borrowers, we used a certain augmentation technique to resample the borrower data so that to match the applicant population, again, if there will be questions on this, I can go deeper into that, but at this point, it's a little bit too technically nuanced to talk about what we did there and how we did it. Well, anyway, so in terms of the methodology of this study, right? So now think about the machine learning process, and this diagram is from a very well-known framework called CRISP-DM, right? So there's a data collection and cleaning at the beginning. Then there is a feature engineering. Now, feature engineering refers to creating new variables or new columns in data based on the columns or features in data that you have. Then there is an algorithm selection, right? Which model would we like to use? Then once we've engineered the features and selected the model, the question is, which of these features should the model use, right? That's called feature selection. Once that's determined, there is something called hyperparameter selection, like related to almost like controlling what exactly the model will be doing. And once all of that is determined, that is, which features will be used, by which algorithm, with which parameters, then there is the final learning process, right? That's where the model actually learns from data about the lending decisions. Right? Again, this is a standard process, as I said, is used essentially everywhere and by everyone in machine learning world. All right, so now what do we do? Right, we start by training a logistic regression model. I will use it LR, an abbreviation LR for it. Right, it's a popular statistical model used commonly in credit scoring methodologies. In addition to that, we also train about 50 different machine learning algorithms. We select the best performer based on what's known as area under curve characteristic, right? That model turns out to be an ensemble of XGBoost models. And just to put things in perspective, this model is very, very good. That is, had we participated in the Kaggle competition, would have ended up in top 10 out of about 7,000 different models. Now, a few words, what exactly is Kaggle and what are Kaggle competitions? So Kaggle competitions are these, think of the Olympics of machine learning and data science, right? So this is where a company puts a large data set and then asks all the data scientists in the world to compete on making the best possible predictions for the data set. Now, the reason I'm bringing it up and the reason it's an important feature of this particular research is that you can always say that, well, you observed gender-based discrimination in your model, but your model is just not that good. Well, here I would say that the model we have is, well, exceptionally good. It's one of the best possible models. Well, all right. So now for these two types of models, right, one is logistic regression, the other is kind of the bestest machine learning model. There are two possible models. We simulate for each of them, right? And for the three regimes that I showed you earlier, remember, regime 1, Singapore, can collect gender and use it however you want. Regime 3 is United States, cannot collect and hence cannot use. And then in the middle is European Union, can collect and use, but not in the final scoring model. Right? It's for logistic regression and machine learning models. And for these three regimes, we run two kinds of models. Right? One is where the gender data is available, and the other where the gender data is not available. Right? We then, of course, use all the kind of fancy tricks and twists about how to do it. We split the data into training and testing, use some bootstrapping technologies, methodologies, for confidence interval estimation. I'll talk about those a little bit later. But think of this, what we're doing, right? So we're saying, how would these top performing models do if they were in Singapore, right, where gender can be used, versus in the United States, where the gender cannot be used, right? And that sort of is the essence of what we're trying to do, right? How would the same firm on the same data, on the same applicants, how would it have performed in one legislative regime versus the other? All right, now, so here, continue a little bit on the methodology, is that essentially, regardless of which model we use and regardless of which legal regime it is simulated in, the ultimate outcomes will form what is called a confusion matrix. It's a little 2x2 matrix where we will have the predicted and actual repays and defaults, right? What predicted will be in rows and the actual will be in columns, right? And somebody who is predicted to repay and then actually repays, right? A person like this is a true positive, right? Predicted to repay and actually repay, right? predicted default and actually default is true negative. And of course, then there are also two types of mistakes, right? Of false positive when we're predicted they will repay, but they actually default, and false negative, predicted default, but they actually repay. Now, of these four numbers, it turns out that only the upper two are relevant. And the reason is that, of course, for people who are predicted to default, we do not give them loans. And so we really never know whether there is some discrimination there. What we do know is if of the people who get loans, right, how can we look at the discrimination and the discrimination there, right? And so one of the metrics for this is called positive predictive value, right? So positive predictive value is what? Is true positives divided by kind of all positives, right? True positives plus false positives. All right, so that's kind of a general methodology, but now comes the gender part, right? So to see where the gender comes, realize that some of these true positives are for women and some of them are for men. And the same for false positives. Some of them are for women and some of them are for men. Again, so here realize that essentially no matter if the model uses the gender of the person or not and how exactly it is using, the person has the gender, right? And so thus this will be in the data. Now, these true positives and false positives, they depend on the model that is used, that is on the predictions, right? And of course, also on the data that is used to make those predictions, as well as the threshold to decide, right, whether we are giving the loan, that is, we're predicting repayment, or we're predicting a default. So these two things, model, including the data, and the threshold. All right, so now what metrics do we use, right? So we use, for discrimination, we use two types of metrics. One of them is called positive predictive value, right? The one that I just showed to you, right? And what we measure is we measure the difference in the positive predictive value for men, right? And the same for women, right? That's metric number one. The other is called weighted mean group difference, right? Where, think about what we're doing. We're looking at maybe let me put it this way. This positive predictive value can be used within a given model, right? So how does the legislative regime change discrimination while we're using the same model, right? It's not a very good way to compare between models. This second metric, weighted mean group difference, can be used between models, right? We're basically calculating at the proportion of correctly predicted women with one model minus the proportion in the other model. And then what we do is we vary this economic threshold, right, between 5 and 30% to essentially capture the different kinds of loans. And we report the averages over these positive predicted values and other metrics. All right, so for the predictive quality of the model, we look at area under curve, and we're looking also at the 95% confidence interval there. For firm profitability, we look at the average optimal profit across the range of thresholds. So now what is the profit? The profit is the revenue multiplied by the number of true negatives minus cost multiplied by the number of false negatives at a particular threshold, and then we average over all these possible thresholds. Well, lastly, we utilize multiple AI explanation techniques, and I'll show you some of these examples a little bit later. All right, so now what do we find, right? So finding number one, and here let me explain you how to interpret this graph because I will show you a couple of them as we go on. Right, so on the horizontal axis are the thresholds, right? So now a very low threshold would be in a situation where sort of the revenue is low, but the default cost is high, right? So we would then like to be very conservative. Now think about it. Unless it's a 95% chance that the person will repay, we will not give them loan. Now, a higher thresholds, right, they are a little bit more relaxed situation where the revenue, for example, is high, but the default cost is relatively low. Now, here realize that these thresholds are kind of in the decreasing order. That is, the high thresholds are on the left and the low thresholds are on the right, right? And on the vertical axis is discrimination as measured by the positive predictive value, right? So now what do we see? We see here that the model one, that is that one that uses gender, in a regime like Singapore, right, in regime one, is significantly less discriminatory than a model two that is without gender, for example, in regimes 2 and 3, like EU or United States, right? And in fact, we see that the difference is quite large, right? It's about, on average, about 300% more discriminatory. Now, is this model more or less profitable? Well, very little change, like a 0.25% difference. And in fact, there is almost no difference in terms of the predictive quality of the model. So now, this finding in plain English is that prohibiting the use of gender leads to increased discrimination, decreased profitability, and without changing much the model accuracy. Anyway, that's the key finding number one. And now that we have that, we would like to explore, so why exactly does that happen? Right? So our finding number two is trying to look at that, right? So let's try to understand now, why exactly does this happen? Right? So I will give you a stylized illustration, and to understand this stylized illustration, we need to first kind of understand 4 facts, all of which are true. First, all else equal, women are better borrowers than men. 2, all else equal, having more work experience makes you a better borrower. 3, men on average have more work experience than women. And 4, the majority of past borrowers are men. So let's see how these facts together would lead to a situation like I just explained to you, right? And here is a little infographic. By the way, this is from the INSEAD knowledge article on this topic that we wrote. I'll show you a link at the end of the presentation, right? But anyway, so think of what's going on here. So the size of the circle is the work experience. Small circle are 1-year work experience. Big circle is 5-year work experience, and the red circle is 3-year work experience. And now imagine the situation is the following, that the threshold, that is the risk threshold, is such, so here is the risk threshold in the middle, it is such that everybody with 1-year work experience are below the threshold, and they should be refused the loans, no matter whether they're men or women. Everybody with 5-year work experience, they should be issued the loan, again, no matter whether they're men or women. Realize that this is very much consistent with this all else equal, having more work experience make you a better borrower. But then imagine the following. Imagine that the people with 3-year work experience, women are above the threshold and hence should be granted loans, while men are below the threshold and should be denied loans. Again, this is consistent with this all else equal, women are better borrowers than men. Now, also look at this, if you look at this sort of red and green circles, right? So here, the color of the circle, red means a woman and green means a man, right? So here we would have men on average have more work experience. Now realize that among the 5-year work experience, 5 out of 6 people are men, right? And men are the majority of the training data. Again, here, I believe that there are 6 women, and what would that be? 12 men, right? So essentially, this illustration, right, is kind of matching these 4 facts. Now, now that we understand that, what will happen if we know gender? Think of what will happen if we do not know gender. If we do not know gender, then all the 5-year experienced people will be granted loans as they were before. That doesn't really matter. Just on work experience alone, we can make this decision. All the 1-year people will be denied loans as they were before, but all the 3-year work experience people will now look more like men, right? Because there are more men in that group. The 3-year men are below the threshold, and therefore all the 3-year work experience people will be denied loans. Okay, so I hope you now see how this impacts both discrimination and profitability. So realize that only 1 woman out of 6, so I'm highlighting her here, is granted credit, right? So in other words, the number of women who got credit dropped down from 3 to 1. The number of men who got credit didn't really change. 5 were getting before and 5 are getting now. And of course, on the profitability is that these 2 loans were above the threshold, right? They were profitable loans, which are now not given, right? So therefore, the profitability also goes down, right? Discrimination goes up, profitability goes down. Right, so I hope you now, with this kind of stylized illustration, see basically how this works, right? The intuition for finding number 1. All right, so let's go further, right? So finding number 2, we are comparing the machine learning models and logistic regression models, right? And so here again, this dark blue is the machine learning model. In fact, the one that I showed you in a minute, and the green and lighter blue are various kind of variations of that, right? So what do we see? We see that using machine learning model versus a traditional statistical logistic regression, right, makes things less discriminatory and more profitable, right? So in other words, in plain English, these machine learning models are less discriminatory and more profitable and more accurate than the traditional statistical models. And this doesn't really depend much on the regime. So the illustration I'm showing you is for regime number 1, but the same is qualitatively true for regimes 2 and 3. All right, so let's now drill deeper into why discrimination happens. Right? And to understand why discrimination happens, remember that kind of circular diagram that I showed you. Here, I just put it kind of in a linear form here, right? We start with data collection and cleaning, then feature engineering, then algorithm selection, et cetera, et cetera. So realize what's the difference between this model 1 with gender and model 2, right? They have access to the exact same variables, right? Exact same variables, but one of them has gender and the other one does not have gender. Now, how do we do it in our study? Well, we basically exclude the gender from the data set available to the model, right? So in other words, the model 1 with gender has just one extra variable on top of 740 others. At the feature engineering stage, what will happen is there will be various new features derived from the existing features. Just to keep things simple, imagine there will be some x's divided by other x's. Like, for example, it would be the balance on your credit line divided by the limit on your credit line, right? Like a percentage utilization of your credit line or something like this, right? Or the amount you would like to borrow divided by your, for example, annual income, right? So just kind of new variables created from the variables that we have. All right, so now realize that when you have gender, you can multiply gender by these ratios, right? So look at guys, at variables like this, right? So what would that mean? That would mean, for instance, this ratio of income to of loan to income ratio created separately for women and separately for men, right? That is, you can create, in other words, the model that has gender may be able to create new features that are related to gender, right? Gender, of course, could be used by the model by itself, but in addition to that, there will be these new features created by the model. All right, so then we will fix the algorithm selection, as I explained, machine learning model or logistic regression model. Then this model will go for an automated feature selection, and it may select some features and deselect others. Now, of course, because now these models have access to different features, it could be that some of them are selected, like, for instance, look at this here, right? If we have gender, then this kind of, x1 divided by x2 is selected by the model, but it is not selected by the other model that does not have gender. Instead, that model selects something else, x1 divided by x3. This pre-last step, hyperparameter selection, again, very technical. I'll skip it here. And then finally, the model will learn certain parameters. Now, we call them betas here, but also realize that there are two things that can be different. A, because there are different variables, there will be some betas in one model that are not in the other model. But also there will be some betas, like over here between x1, that would be different in one model versus the other, just because one model has variables that the other one does not have. All right, so now with all these technical details, what we do is we sort of apply this and we examine how this happens in our data, right? And for that, we use a model explainability technique called feature importance. So now what is this model explainability technique doing? It is taking all these 740 features, plus, of course, many, many more that the model generates automatically, and then ranks them from saying what is most important for the model and what is least important for the model. And so here is the list of 25 most important features. There are two things that I want you to notice. So one, gender is not among them. That is, gender by itself is not really a very important variable. But out of the 25, 4 are various gender interactions. Like, for example, here, credit to goods ratio separately for men, right, ends up being, that is what, number 5, right, fifth most important feature for the model. Now, credit to goods ratio is itself also important. So here it is, right, somewhere around position number 10, right? But realize that the gender, that is whether somebody is a man or a woman, is actually not. So in other words, in plain English, this discrimination that we're observing is driven not by the gender per se, but it is driven by how gender impacts what the model learns from other features that it has. Now, okay, so that was our finding number 3, right? And finding number 4 from this work is we're asking a question, well, but what can the firms do in this situation? And what we do here is we compare how a firm in a jurisdiction like a European Union, where remember what the caveat is, right? In the European Union, we have a situation where the gender is collected and can be used, but not in the final model that is applied to the applicant eventually, right? So there are 4 things that we looked at, 4 different techniques. 2 of them are related to sampling the data, right? Upsampling and downsampling. I will give you an illustration for that in a moment. One of them is this technical thing related to hyperparameter tuning. I will skip it for, again, it's a bit too technical for a general audience webinar. And the last one is called probabilistic gender proxy. I'll explain what that is again in a moment. But take a quick look at this, right? Realize that all of them are reducing discrimination, I would say by more in some cases than in other. Now, some of them have a cost that is they reduce profitability. Again, some of them reduce it less than others, but some can in fact improve profitability, right? That in other words, there are certain things that the firms can do to reduce discrimination and, as we tell it in this paper, to manage profitability, meaning that to kind of have a small impact or maybe even a positive impact, right? So in plain English, collecting gender and using it in pre-processing and training models allows to significantly decrease discrimination while managing profitability, even when gender is not used in the scoring models, like it happens in the European Union. And the graph on the left is basically showing how things work across kind of all these different techniques. Now, here, this purple. Sorry, not the purple. This blue line, right, dark blue line, is what I showed you earlier, right, when I compared the 2, and the others are kind of different permutations of these techniques. Right, so now, what exactly are these techniques and how exactly do they help? Let's first look at this downsampling and upsampling ideas. So here, what is upsampling and downsampling, right? So both of them are ways to rebalance the data. Remember that the data is such that there are more women borrowers, or more sort of men in the data than women, right? Women are a minority. And so what can we then do, right? We can take our data and remove some of men from the data. So in this particular illustration, right, so I removed these 5 men from the data, right? Once I do that, my data set becomes approximately balanced, that there about the same number of women and men. Now, in this situation, of course, what will happen, right, is that my, again, 5-year experienced people are all above the threshold, 1 year are all below threshold, as they were, right? But my 3-year-old people now are equally balanced between women and men, and the model will therefore learn that they're more like women, right, than before, and consequently will give loans to all the 3-year people. Now, realize that this will reduce discrimination. That is, the number of women who get loans here is exactly the same as it was had we known the gender of the applicant, but the profitability is lower. And again, why is profitability lower? Well, it is because these men are actually below the threshold, right? So the firm is actually, on average, losing money on them. They should not have given them loans. So that is why I reported to you here that there is a cost, right? Discrimination is reduced, but at the cost to the firm, right? Basically, we're issuing a certain number of bad loans. Now, upsampling women is a very similar idea where we will create synthetic data points that look like the women that we have in the data, right? So again, think of this. In the downsampling men, I'm removing some actual data points, right, to make the data set more balanced. In the upsampling women, I'm creating synthetic data that looks like the data that I have, right, to have more women in my training data set. And the result will be exactly the same, right? So observe that these 2 are, in fact, exactly the same situations. So this rebalancing, again, done one way or the other, has more or less the same result. Now, what is the last thing that we could do? The last thing is called, anyway, so sorry, here I forgot to say this. So now in plain English, what does this mean is that upsampling and downsampling makes the training data more equitable, and this reduces the bias, but also reduces profit. Now, the last part is what's called probabilistic gender proxy. So now what is probabilistic gender proxy and when can it work, right? It can work in companies that operate in multiple jurisdictions, where you can use the data from one jurisdiction, let's say like Singapore, to train a model that will predict whether a particular applicant is a woman or a man. Then you will use that model trained in one jurisdiction on the applicants from another jurisdiction to predict their gender, and then use that predicted gender in the model as opposed to the actual gender of the applicant. Now, to see how this would work in this infographic, so realize that I have situations like before, right, where I have kind of green circles and red circles, right? The outline of this circle is whether somebody is actually a woman or a man, right? A woman in red and men are green. And then some of them are predicted correctly, like here, right, which is a woman that is correctly predicted to be a woman. Some of them are also predicted correctly like this, which are men correctly predicted to be men. And then, of course, we have the opposite situations, right? So this is a man who is, in fact, incorrectly predicted to be a woman. Here's a woman who is incorrectly predicted to be a man, right? And so, of course, this model will make occasional mistakes. But as I mentioned to you earlier, on our data, the gender could be correctly predicted with more than 90% accuracy, essentially meaning that kind of there is enough data to predict whether somebody is a woman or a man with fairly high degree of confidence. Right. So in plain English, one can first create a model to predict gender with very high accuracy, and then use such predicted gender proxy instead of actual gender. So in our data, this reduces discrimination and increases profitability kind of slightly. All right, so let me now summarize. So to conclude, right? So we had 3 research questions, right? One research question was, do certain anti-discrimination laws paradoxically increase gender discrimination? And the answer is yes. The legal regimes that force gender exclusions, like in the US and EU, lead to increased AI discrimination, decreased model predictive accuracy, and decreased profitability. Now, related finding for this is that machine learning models actually favor better than the logistic regression models across the 3 regimes on the data that we studied. So kind of insight in plain English is that prohibiting the use of protected attributes like gender in AI models is a bad idea. Finding number 2, or research question number 2, why does discrimination occur? And we show that it mainly occurs because of the feature engineering and selection, as well as through hyperparameter tuning. I understand I skipped that today a bit. So in plain English is that gender is not an important variable by itself, but it is important through how it impacts what model learns from other features that we have, from other like hundreds of features that we have. And the research question number 3 here was what firms can do to reduce discrimination. And here we have kind of the good things, right? Use machine learning algorithms as opposed to logistic regressions. This can be done in any regime, even like in the US, where the gender is not even collected. Like better things, use and collect gender in training models, for example, to upsample, to downsample, to do the gender proxies. Firms in Singapore, in the EU can do it. And of course, the best one is, in fact, collect and use gender in both training and screening models. Here, realize that only firms in jurisdictions like Singapore can do it. Firms in the European Union, well, can have gender, but cannot use it in screening models. Firms in the US, like jurisdictions, don't even have gender. So inside in plain English, there are things firms can do to reduce AI discrimination while managing profitability, and more and better possibilities in less restrictive regulatory regimes like Singapore or European Union. Well, with that in mind, I thank you very much for kind of listening through the presentations. If you want to learn more, so here is the link to the actual research paper. And I take this opportunity to thank my co-authors, my former PhD student, Stephanie Kelly, as well as David Hardoon and Andrea Henrik, who are from the Union Bank of the Philippines. Now, there is an so this is an actual research paper. It may be a bit technical for some of you to read, but there is an HBR version of this paper and an INSEAD knowledge version of this paper. The INSEAD knowledge in particular has those infographics that I showed you with green and red circles, which I believe is just a nice way to explain the findings. So I thank the INSEAD knowledge team for working on those infographics. A couple more things about this work. So this work was recognized by United Nations as one of the global top AI projects to advance sustainable development goals which year was that? In 22, I believe. All right, so here is the link if you would like to read more about this project and about other 99 projects on that list. This work also underlines Monetary Authority of Singapore's principles on fairness, ethics, and transparency, something called FEED Guide, which was, I would say, among the first, if not the first, AI regulation done back in 2018. Of course, today in 23, 24, right, AI regulation is kind of all over the place and on everybody's mind. Realize that this was 5 years ago, so the team there were true pioneers. And my co-author, David Hardoon, is in fact the one who was working on that. Anyway, so with that in mind, I thank you for your attention. If you want to be connected with me on LinkedIn, here is a link, or you just can scan a QR code. And let me now, maybe I will not, okay, I can continue sharing, but let me invite Virginie back into the room to manage Q&A.
Yeah,
again, thank you so much.
Thank you very much for the talk, super insightful. I'd like to remind, maybe I have an echo with you, Anton, I think. Maybe I'd like to remind the audience that you can drop all your questions in the Q&A. And I'm going to start with the first one we got from Desiree. So about your reverse engineering for doing the gender prediction, like a solution to try to mitigate this issue. Is it even necessary? Why not create a third gender to kind of have a responsible borrower feature and then be able to solve it this way? And I would also ask the question, like, if we want to predict gender, is it not a bit risky based on the law that's asking you not to use it?
Okay, I admit I don't fully understand the first question. So you would like to create a responsible borrower feature?
Yeah, feature. Like instead of pre-predicting the gender, we would predict a good borrower, responsible borrower feature.
Well, but let's go back a little bit. So in essence, what these models are doing, that's exactly what they're doing, right? So think about this. What we would like to do, we would like to predict this, right? Whether you will repay or not. So of course, that's what the model does already. The question is, in doing that, is the model using somebody's gender or not? And what we show is that the models that predict responsible borrower feature, the ones that are using gender, like these ones, are a lot less discriminative than the ones that are not using gender. Okay, so I hope this answers the first question. So in other words, predicting whether you are a responsible borrower, that is whether you will repay, that's the holy grail of what the model is doing. But it can do it with gender or without gender. And maybe let me go back a little bit here, is that in countries with this regulatory regime, there is really no choice. The model will be predicting responsible borrower without gender. In a country like this, the organization can make a decision that they will not use gender. They have gender, but they can decide not to use it, or they can decide to use it. Right? Now, Virginie, to your second question, whether this PGP is legal, right? That was your question, right?
Yes.
So in fact, it depends a little bit on the different regulatory regimes, and in the paper we have a little discussion of that, right? But let me highlight the important part of how it plays out in this regulatory regime, right? So what does this regulatory regime says? It says that you can use gender in training a model, but whatever model you train, right, and then the model that you apply to a borrower, that model that you apply to a borrower cannot use borrower's gender. Right? And from that perspective, this PGP is fully legal. That is, I will use it up until this stage, then I will remove the gender, and the model that will be the screening model. Let me go back. Where is this illustration? So in other words, the gender will be used here, but it will not be used there, right? And that alone is already enough. Now, remember why this happens. By using gender in this model, I will also change how this model learns from other things. like what it learns from your profession or what it learns from your work experience, for example, so that once I remove gender here, the things learned from your profession or the things learned from your work experience will be a bit more, well, let me say a bit less discriminatory toward women.
Okay, super clear. Thank you. So another question I have for you is, considering it's super important based on your findings that we have the data on this like gender, or I'm thinking also about ethnicity for France, because we don't have the right to get ethnicity data. Do you think the companies should be looking for data from other jurisdictions when they can get these features, but at the cost of representativeness of the population?
So in fact, a very good question. Let me comment on something which I skipped today, but we talk about this in the actual research paper. So now, why did we look at gender, right? So the question is a bit generic, right? About general protected attributes, right? And the problem here is that many of the protected attributes are not universally understood around the world. Right. So, for example, think of race. Right. Race in the context of the United States means one thing. Right. Race in a context of another country could mean something very, very different. Mm-hmm. Right. So, therefore, there is indeed a lot less kind of generalizability there. Right. But with gender, it's a bit more universally understood around the world. Right. And so things like we discuss here, maybe you can say that we have a little bit of a maybe an upper bound on what will actually happen, right? But because, for example, your example from France, right? So, of course, can you find a data set whether the ethnicity means the same thing as it would mean in France, right? So, again, I'm not sure, right? But gender, and especially its relations to professions, changes in work experience due to family and so on, right? So this is very much universal around the world. Right. And so that's why kind of what we say here maybe is an upper bound on what you can expect, or kind of how much bandwidth can you get from these type of things.
Mm-hmm. Okay. Fantastic. So another question I have from Richard is, I'm going to read it just to make sure you have the right wording. So given one of machine learning's inherent output of finding and confirming biases, even uncomfortable biases, could machine learning be used to help regulators provide sensible rules that protect sections of society while allowing business to flourish?
Great question. I did not quote the name of the person who asked it, but so I would say that there are really two parts to this question. Is that part of the reason why machine learning models are biased is because they're learning from human data that is biased. And for good or bad, we actually can slice and dice these machine learning models in better ways so that we can slice and dice human mind. Right? And in particular, realize that there's heterogeneity also of human minds, right? So some people may be less biased than others, right? So using machine learning models, we can ask more questions so that we can get more precise answers about biases, and we can therefore also be a bit more precise about debiasing. Right? So this is sort of good news, right? You need to think of this as while machine learning AI systems are black boxes, they're a lot lighter than the black box of our mind, right? At least for now, right? So therefore we can kind of slice and dice them a lot more. Now, we have been slicing and dicing kind of in an indirect sense our mind for a lot longer. So it may seem that we understand the mind more, but practically speaking, right, we can do many more things to understand biases in machine learning models than with the human mind. Right, so that's one thing. Now, would it be possible to then distill that to a set of simple rules that regulators, for example, can adopt? I personally think that no. And in fact, this study is almost an illustration of this. So think about now, why, where is my diagram with the countries over here? So again, why do we have these legislative regimes, right? Because regime number 3 is precisely an attempt to do that, right? Regime number 3 will say, well, don't even look at gender. If you don't look at gender, how on earth would you discriminate against people, against something that you don't even look at? And again, look at how convenient this is for a response from a company like this, right? So we have not and never will make decisions based, in fact, we don't even know, right? truth be told, that by kind of hiding ourselves in that situation, right, we also prohibit from even figuring out whether we have discrimination or not. So in fact, what this research shows, and that Singaporean regulation that I mentioned a few minutes ago, it actually gives companies the ability to collect and use this data, but it also makes them responsible for the outcomes, right? Which I think is more proactive approach. It's more, I think at the end of the day, it will be more fair, right? When it will give the rights and responsibilities, right? Because otherwise, kind of creating these simple rules will put certain restrictions, but will also remove certain responsibilities. And I would say I like the first part, but I don't like the second part. And on the balance, I think giving rights and responsibilities is better than removing some rights as well as removing some responsibilities.
Nice. And I think there is a question also from the audience that's kind of following up on this, is like, does it mean the use of gender would only be authorized for a company that has some kind of certification to like use this data in a good way, and how to guarantee the people are going to use it properly in the models? So,
well, yeah, that's very, very big question in much of the AI regulations today, right? So should we like think of this like a large language models, right? So there is quite a lot of conversation about, you know, certifying them, right? Or applying a similar logic as we do to the medical devices, right? Or to new medicines, right? Where you need to test it kind of first to prove that it works without certain side effects. I would say that the Singaporean regulation does it a little bit different. It basically says everybody can do it, but everybody is responsible for the outcomes, right? And so, of course, you know, discrimination based on, let me maybe go a little bit here, right? So kind of these things are very much in the court of public opinion, right? So as well as this, right? So here, I mean, I didn't tell you all of the story, but the regulator in the state of New York, right, where Goldman Sachs is, then filed a certain, well, how, I don't remember exactly the name of the, but basically there was a certain investigation, right? And they, in fact, came to a conclusion that there is nothing unlawful that Goldman Sachs and Apple were doing here, right? But in the court of public opinion, this nevertheless exists, right? So now, bottom line, do we want certification for everything? We probably don't. It will be too much kind of administrative burden, right? But do we want a situation where firms will be responsible for how they do it? I would say yes. And that really goes back to the previous point. I think that given the rights and responsibility is more better, I would say maybe, than removing the rights, but also removing responsibility. Okay, great. Now I'm going to deep dive in a more, I would say, technical questions on the work you did. One question I have is, did the dataset contain features? So the dataset you used from Kaggle, I think, was derived from the full sets of bank transactions provided by open banking standards. I think it relies to some kind of legitimacy to the data, something like this. So in short, I don't know, but an answer to a very related but a slightly different question is, reflect on why would a commercial, so these Kaggle competitions, they come with real money, real prize money. I believe this one came with $70,000 prize money. So now ask yourself a question this, now why would a company put a large data set of their data and complement it with a serious amount of money, right? For the open public data science community, machine learning community. They would do it because they would like to know what are the best possible models to make the predictions that this company would like to do, right? Which is predict whether you're a responsible borrower or not, right? So this gives us a good reason to believe that data is as close in general to a data that a real fintech lender would use, I realize that home credit has no reason to kind of fake this data in ways that would defy the purpose of prediction competition, right? So therefore, whether this data complies with some standard or not, I don't know. But at the same time, this data is as close to a data as you can find, to the real data based on which fintechs would be issuing loans. And then another, again, an answer to a yet even further removed question is that while this is the data that we used in this research study, it's a publicly available data set. That there's a lot of kind of convenient things about using that as opposed to something else. Remember that this work was motivated really by conversations with multiple lenders who observed this exact thing in their data. All right, so therefore, this gives me qualitatively the exact same thing in their data. So this gives me a reason to believe that this data is very representative of what the real borrower data on which the real algorithms that really issue credit to people are trained.
Yeah. Okay. If we have time for one last question, someone asked like the probabilistic gender proxy model. So I think it's when you show the prediction of gender seems similar to the up and down sampling. But there's not like 100% accuracy. So the question was, how come shows a higher improvement in discrimination metric with one compared to the other, I think?
So, well, the short answer is no. It doesn't look like an up and down sampling. It's a technically speaking, a very different way to do it. Now, let me maybe walk you through again. So in down sampling, realize what happens. My data set becomes smaller. If I have a data set with, for example, think of the data set with 20% of women and 80% of men. And let's imagine I have 100,000 data points like this. To downsample it to 50-50, I will lose 60,000 data points. That is, I will have a 50-50 balanced data set with only 40,000 data points, which is 2.5 times smaller than the data set I had originally. Right? So that's why the model I will train on that smaller data will be a worse model. It will be more equitable, but it will be not as good of a model. Upsampling, so again, in this 80-20 example, right? So what I would need to do is for every real woman, I will need to create 3 quote unquote fake women, right? And there are various techniques for how to make these fake women look like real women, right? But nevertheless, they're not real data points. I will have a data set with 160,000 data points, of which 100 is real data and 60 is not. So again, the model that I will train here will be quote unquote a worse model that I would create based on 100 real data points. All right, so that's how upsampling and downsampling works. Now, this works very differently. That is, I still have my 100,000 real data points where I am adding a new column to that to the data set, where what that column is a predicted gender of a person. Once I have that column, I can do all of these tricks, right? That is, I can create these ratios differently for not real men and women, but for predicted men and women, and so on and so forth, right? And so there will be a little bit of a kind of impact on the model quality here, right? Because this is not real gender, but rather it's a predicted gender. But in a situation when gender is so highly predictable based on everything else, right? That model will not be kind of that much worse than the model that I would have with real gender. Right? Okay. Well, Virginie, so we have 1 more minute or 1 or 2 minutes to go. So if you have a very quick question, we can do it. If not,
I think we're fine. I think I'll just recommend for the other questions to go read the article, the publication.
Absolutely. Thank you very much, Virginie. In fact, again, to our audience, you can read. There are 2 things to read here. One is the actual technical paper. By the way, it is published in what is called open access. That is, normally you would need, register or pay to access this article. But thanks to our industry partners at the Union Bank of Philippines, we actually were able to publish it free for all, right? But that number 1 listed thing here is a technical work. I'm not sure how readable it is to kind of everyone. But the HBR version and INSEAD knowledge version are written very much for the general public in mind. Now, to close up this, thank you very much, Virginie, and thank you, Digital at INSEAD, for inviting me. It is a particularly great pleasure to be talking about this work kind of 2 days before the International Women's Day on the 8th of March. So I take the opportunity to congratulate all the women with their kind of holiday, 8th of March. And I would also remind all the men in the audience to, think a little bit more and to congratulate their women, in their families or their colleagues and coworkers. So let's take this opportunity, to thank the women and recognize them for all the great work that they're doing. And I hope this work that we showed here makes the world a little bit more equitable as well.
Thank you.
Thank you so much.